Good afternoon. Thank you for being here on time. I'm going to speak on securing your data in Postgres. And my name is Payal, and I'm a database administrator with OmniTI. We are a consulting firm. I've been working with Postgres for the past 5-6 years or so, and have had a great experience. Worked with MySQL as well. Had a great experience as well. The purpose of this talk is to give an introduction about what exists in core community Postgres flavor as far as data security is concerned. After this talk, the hope is that even if you won't walk away knowing the nitty-gritty details of each one of these, you will know what exists and what you can do without having to go to third parties. The aim is also that if you're coming from the MySQL world, maybe you can compare and contrast the various features you will see here. I'm going to try to mention MySQL a couple of times, not too much. So first things first, this is the Postgres security page that contains all information regarding the latest vulnerabilities, which patches, which minor versions are vulnerable, which have been patched. And so if you are running Postgres in production or plan to do so, you might want to, or you definitely want to have this bookmarked. This is the link for that page. Make sure you check it a few times every week. Postgres tends to release minor versions with patches every 3 months or so. But in case of serious security vulnerabilities, it releases a patch as soon as the bugs are reported and it has patched it. So starting with Postgres authentication, Postgres manages authentication a little differently. This is the HBA file, the host-based authentication in Postgres. This is the file from where you manage authentication. I know in MySQL you just have to add a user at hostname inside the database. Interesting discussion I had with the community member of MySQL, I forget the name, Dave. Yes, Dave Stokes, thank you, at Scale in March. And I asked him that because that part of MySQL bugs me a little bit because I started my DBA journey with Postgres. And in Postgres, as long as you're a single user, that's all you need. So in the user column, that's the username. In this case, this is the default file that you get once you install Postgres. So in MySQL, it doesn't, to me, a user is an atomic value. It doesn't matter where it's connecting from. It should always have the same privileges because it's one user. So that's my logic. So I asked him about why MySQL considers that user coming from different addresses can have different privileges. And he said that basically the second developer that started working on MySQL Community Edition was a DB2 person, and he just copied how DB2 managed roles. So interestingly, that satisfied me because that told me, oh, there's not a reason behind it that I don't know of yet. He did say that they are working on changing that and making it more compatible with the other databases, Postgres included. On vice versa, Postgres does have a DB parameter to manage roles similar to MySQL. If you really need to do that, if you're thinking about moving from MySQL to Postgres and don't want to change your roles, there is an option in Postgres to have a user at hostname, but you lose some of the security-related options with it, especially SSL. Not whole of SSL, but some parts of SSL that you can do, but that option is there. Now, when it comes to types of authentication, if you noticed in the previous default configuration file, we had trust everywhere. Trust is as obviously, it doesn't require a password for the user, and that's default. Override that as soon as you install Postgres. There's others, like password is the main one, wherein you require a password, but it's not encrypted. It's not hashed either, so it's transferred in plain text. If you have SSL enabled, it's okay to use it, but in most cases, if you don't, then you're not gaining on security too much. Up until Postgres 9.6, which is the last year's version, and latest now this year is Postgres 10. So up until 9.6, the best we had was MD5, and I know in MySQL it's SHA-1. Yeah, that's what I remember. But MD5 was the best Postgres had, and obviously people had problems with it. However, I would just like to point out that the way Postgres does the hashing is not as bad as MD5, basic MD5 is. So basically Postgres uses salted random hashes, which it adds the response. So basically it does what Scram does, which is a new separate authentication type available in Postgres 10. But the way Postgres used MD5 before, or even in 10, it supported, is not as bad as using just the password hash and sending it across. It uses salted random values as well, appends it, and then uses that for authentication. However, with Scram, you do get a benefit in that so when you're using MD5, so PG auth ID is your catalog table where your password is actually stored. And up until MD5, where nothing better was available, if you looked at the role password column, you could see the password hash, not the plain text, but the hash, which wasn't that bad, but wasn't great either. With Scram, the best part is that even inside that table, you cannot look at the password hash. You can only see that what algorithm is being followed, how you can create the hash, but you cannot see the actual hash. You get all the details for calculating it yourself. So it's safer in the way that even if somebody gets access to your database, they cannot get the password hash straight away. One other thing I'd like to point out is the SHA that Postgres decided to implement starting with is 256, not 1. The decision was mainly driven by the fact that when they started working on this, SHA 256 was already available. So they thought it's just better to go with that instead of SHA 1. So yeah, one thing I would like to point out again is that and I might be wrong, but when I've tried to do this in MySQL, if I don't use the password function, it accepts the value in plain text and it stores it in plain text. So no? Okay, so maybe I was using an older version. I think I was using 5.6. Yeah, so it changed in 5.7. Awesome, great, okay. So yeah, that thing, not in Postgres. It's the worst is hashed as long as you're using MD5. Don't trust, already mentioned that. One way to completely avoid doing this is in the packages that if you're creating your own packages or if you're initializing your own data from scratch, you'll use the command called initdb to create your data cluster in Postgres. And there's an option with that, -a, which lets you override trust. So in this case, if you use this option to create your Postgres cluster, what it's going to do is it's going to create the default HBA file without the trust authentication that we saw earlier. It's going to have MD5 instead. Now you can also put Scram in there if you're really disgusted with MD5, but yeah, MD5 should be good enough for now. One tip, make sure you make good use of reject. It's basically kind of like revoke, but only for authentication. You can use this in place of trust, MD5, and other options within the HBA file itself. It's just another authentication option. And it does basically what it says is that it will make sure that that user for that database coming from those set of IPs will not be allowed to log in. Why it's important or useful is, number one, make sure your super users cannot access the database from a remote location. Usually you wouldn't want that to happen. And more importantly, you might have a large group of IPs you might want to allow logins for, but some of those you don't. So instead of having to list each of those that you do want to allow, you can just list the subnet mask to allow, and then before it, you can add the reject for the individual IPs that you don't want to log in. Another thing to keep in mind here is when you do make changes, any authentication-related changes, most of those for your day-to-day purposes will only involve you changing the HBA file, the host-based authentication file. But once you change it, you have to, it's kind of like equivalent of doing a flush privileges. You have to log inside Postgres and issue this function so that Postgres knows to reload that file. One thing I did want to mention, I think I removed that slide, was there is no fall through in HBA. So if the first line that meets your host plus user plus the database that it's trying to access and whatever authentication has been specified in that first match is the match that Postgres uses to decide whether or not to allow. If that fails, it's not going to check the lines after that line to see if any other line allows it. There is no fall through there. So any questions here so far? Okay. Moving on to ACLs. Grant and revoke. I'm sure everybody knows this. Anybody who wants an explanation? Great. One thing I wanted to mention here is revoke between Postgres and MySQL works differently in one sense in that when it comes to revoke all, I know MySQL allows that, but it's a little iffy in the sense that if you grant star dot star, then you have to revoke from star dot star. You cannot revoke from a subset of tables, right? But that's not the case in Postgres, so I like that part between the two. So I can revoke selected tables, selected privileges, doesn't matter how I granted them, if I granted to everybody, but I can revoke from some. So I like that. Oh, this I've already mentioned, irrespective of location. Coming on to the actual privileges that are allowed, basic set of privileges here. One thing I would like to point out is the usage privilege. That's common on first look between MySQL and Postgres, right? But it's not really. Usage in Postgres is very different from usage in MySQL. And here I would like to say that MySQL does it better, even though Postgres does it for added security. So what usage in Postgres means is that you can give a user, so let's say you have a function in a schema and you create a user and you can give the user and execute on that function, but unless you specifically grant that user usage on the schema, that user cannot even look inside that schema. It doesn't matter which tables inside that schema or which function it has privileges on. It just can't see those. So oftentimes, you have given your privileges to the objects, but you haven't allowed usage on a customized schema to a user, and you will find that your user is unable to run those functions or read those tables, and you're baffled, and then it turns out that, oh, you just had to grant usage on the schema. So that gets a bit frustrating at times, but added security, right? On the other hand, in MySQL, as soon as you create a user, MySQL grants usage on everything just to indicate that to MySQL that, hey, this user exists now, it's a part of you. Transactional DDLs are a huge benefit, especially when ACLs are concerned. So in Postgres, what I can do is I can, in an explicit transaction, I can grant select on a table to a role, and then I can do a rollback, and I can be sure that that's not really applied. When I tried to test this on MySQL, I expected, so MySQL does not have transactional DDLs, but what I expected was when I would I would use the grant statement within a transaction, I should get an error, but I did not. So when I did a rollback, it said okay, and then when I checked the privileges, I saw that the privilege had actually been granted, even though I did a rollback. So that was a little bit misleading. Default privileges, I believe, is another thing in Postgres that's new. Not in Postgres, I think it was introduced in 9.3. And it's basically altering schema privileges as soon as the schema gets created and before you create any other objects inside the schema. So let's say you have a schema, you know that all the tables inside the schema need to have the same privileges for the same subset of users. You don't want to grant those individually to tables. You want that as soon as anybody creates a table inside the schema, I want the permissions to be handled in an automated fashion. So this is how you can do that. The one thing to take note is that if there's tables already existing in that schema, this won't apply to those existing tables. This will only apply to tables created after you've set the default privileges on the set schema. So if there's already tables in a schema that you're setting defaults for, make sure you're changing or adding those privileges to the existing tables separately. You have to do that separately. Roles and groups. So in Postgres, there's no concept of a group role. It's still a role. It's a member. So members are roles and groups are roles. And so the benefit of this, I think MySQL handles it similarly, is that you can grant privileges to group roles, roles that you consider to be groups. Now, how are you going to distinguish these roles from member roles? You're going to do that by making sure, number one, sales is not allowed login. So in this case, because it's a group role, nobody should log in as sales. And number two, all privileges, none of the privileges are given to the individual Bob and Rachel here, individual roles. So in that case, whenever a new employee joins or leaves, all you have to do is exclude or include them into the group role here, and you're done. You don't have to deal with their privileges and removal and such. Column level ACLs, I believe MySQL has these too. Basically, you can provide privileges per column or on a subset of columns within the table. And one thing to note here, the reason I used update as an example is because when you do grant just the update and not a select, you need to know that select is implicit in the update. So if Rachel here has the update privilege on the name column, she also has select on name, because she is going to, under the scenes, read first before she can update. And finally, in ACL, be careful of using the public schema too much. By default, it has all privileges for all users on any object that's created directly inside it. And same goes for any function created in it. Any role is going to have execute privileges on it. So as far as you can control your schema design, it is recommended to have separate schemas, customized schemas, so that when you create a new schema, by default, a new schema, a non-public schema, is never going to have any privileges for any role unless it's the super user or the owner of the schema. Any questions so far? Great. Role level security. This is relatively new in Postgres, was introduced in 9.4. Basically, if you have a very large table with a lot of rows, in this case, the accounts table, and you might want that a manager of one department should only be able to see rows that belong to employees in their department. And you don't want them to see rows of employees in other departments, even though it's the same table. So basically, you want to have row-level control on who gets to see which rows. And Postgres now has a way, 9.4 onwards, to do exactly that by creating policies on tables. This is a sample, very simple policy, which basically is saying that create a policy named account managers on this table where a manager can only select rows that have its manager value set to the current user that's actually querying the table. So manager equals current user. Current user in Postgres is a keyword which returns which user you're logged in as. So in this case, basically, whichever user you are, rows corresponding to your manager value will only be visible to you, unless you're a super user or unless you have the bypass RLS attribute to your user, to your database user. This is sort of like an exception if you want for a few of the non-super users so that they are exempt from these policies. They can see all the rows, so you can use this attribute on them. Table owners by default are allowed all rows, allowed to see all rows. They are not subject to any policies. If you do want them to be subject to policies, you can force that by using the force keyword when you're enabling row-level security. So by default, row-level security is disabled on all tables. You have to enable them on a per-table basis. Why? Because number one, it's not always needed. It's not a feature that's always needed. Number two, it has obvious performance penalties. The default policy for as soon as you enable row level security is all deny. It's going to deny everything unless you have a policy. So make sure that if you do want to set up a row level policy in prod, you do it in a single transactional format. So you enable row level security and you create the policy in the same transaction. And finally, there's exceptions. So for example, foreign integrity checks are not subject to row level security because it will be very hard to maintain the foreign key integrity. And there are other edge cases with row-level security that's being improved upon in every version. 10 also has some very major improvements that we're going to talk about in the next slide. But mainly the exception is that there is an option to sometimes select rows and keep them with yourself as a user for an update at a later time. So if you do that and your row-level policies are changed while you have it selected for a future update, it's possible that you can see information later in your transaction that you're no longer supposed to see. So that's one of the edge cases. And speaking of what's new in Postgres 10, the current version, up until Postgres 10, you could have multiple policies on a table, but all those policies were permissive, as in if a query or a user had to go through multiple policies before accessing the rows in the table, the automatic logic applied was an OR logic. So as long as it can go through, it can pass through any one of the multiple policies, it's allowed to see the rows. 10 onwards, you have an option for restrictive row level security, which is basically an AND logic. So unless a user is allowed access through all of the policies that exist for a table, it cannot access the rows. Oh, and permissive OR logic is the default. You have to enable or set restrictive if you want that. On to SSL and TLS. It's a single parameter in Postgres. Turn it on. It requires a restart. Creating certification files and key files, and these three in pink are basically the only things you would need to basically enable SSL on Postgres. It's pretty simple. The one thing to note is that the permissions of the certificate should be 600. If they're not, Postgres wouldn't just ignore the SSL parameter when you're restarting it. It will fail to restart. It will just basically say, I cannot start because your certificates don't have a valid permission. So that's a bit scary. As far as modes are concerned, SSL authentication provides 6 modes. The one is in green if you do decide to enable SSL. The one in green is the one you want to stick with, which is verify CA or verify full. Both are good, but for the especially paranoid, verify full works because it also ensures that the host name is the same as what's mentioned in the server certificate. For clients, if your clients don't have SSL support, you can always use tunneling, the basic way. Any questions so far? Cool. Event triggers, I believe MySQL does not have these, so this is something new as well. What is an event trigger? So it's just like a normal trigger, gets fired when an event occurs. The only difference is it gets fired when a DDL event occurs. So you can set triggers for a drop table, for a create table, for a drop view, any sort of DDL you can create them on. Why is it useful? It's super useful for auditing. So if you're handling auditing in-house, if you're doing everything kind of following a do-it-yourself approach, you can set up triggers for, say, alter table columns, or when anybody is altering privileges. You can set up a trigger so that it either disallows based on whatever your policy is, or post that information that who changed it, at what time, and what exactly was changed, and on which objects it was changed. So that's possible using event triggers. Quite obviously, it's possible to place a trigger on a drop view or a drop table and say, you cannot do that, that's an important table. So accidental data loss prevention. Trigger-based replication. MySQL has had logical replication since like forever, but Postgres only introduced it in core in Postgres 10, the current version. Up until then, trigger-based replication was the norm, for logical replication, unless you were using the default, which is binary. And with trigger-based replication, you could have event triggers so that your DDLs would be replicated and not just your data. So that was possible. And finally, ownership. Again, when it's related to security, not just privileges, but if you're changing a table owner, you can also set event triggers for that. So the most important use of this is when your developers might have access to your database and might want to create some tables and not notice that they're not logged in as, or they're logged in as their own user, and you don't want them to own the objects that they're creating in your production database. So just to prevent those kinds of things, you can have an event trigger. Just like a normal trigger has specific events on which it can be defined, before, after, insert, delete, update, and in the same way, DDL command start, DDL command end, and SQL drop are the events available to you for event triggers. So the first two, I think, are fairly obvious: before the DDL command is executed, after it's executed, and finally the drop statements. Postgres 10 has a new event type called table rewrite. On certain operations, could be alter column, for example, or alter table, sorry. Sometimes, depends on what you're altering, it might require Postgres to rewrite the whole table under the scenes, and that event can now be captured. So when is it useful? When somebody is trying to alter something at a very high traffic time. So you can have an event trigger that checks that, okay, this event is trying to happen and it's not a good time, so I'm going to tell them, I won't do this right now. Please contact your DBAs, schedule it on off hours, and then do it. So very useful for preventing those kinds of slowness issues. This is an example of what an event trigger would look like. In this particular case, I've used a drop event trigger. The function that I'm selecting from is an inbuilt function. It basically returns me all the objects that are getting dropped. So if I use this for a view and there are cascading views on it, I'm going to get returned a list of that view as well as all the views that are dependent on that view that will be dropped. So I can use that for either auditing or in this case, I think it's just a simple, you cannot do this for a particular table. Very useful. On to auditing. This is a very simple example. So Postgres, unfortunately, does not have an in-core auditing extension or a feature. There is a third-party extension that I'm going to briefly mention, but largely, if you want to audit data right now, you have to implement it yourself. This is the most basic way to do that. It's basically a diff capturing trigger. New minus old, put it in the audit table. Storage can be an issue, though, especially with busy tables that are being very frequently updated. So 8 store here, or you can also use JSON and JSONB formats that are in the later Postgres versions. Basically, just what this is doing is selecting what changed between the new state of the record and the old state. And it's only capturing the columns that changed and storing them in a single key value paired JSON style column. So what that does is, depending on how much of the row is getting changed, only the size relative to the changes is getting consumed. And that leads to a lot of, to significant storage savings. This is the third-party extension I was talking about, PG Audit. It was going to be part of core, but unfortunately couldn't, core extension. So Postgres so Postgres core code is a separate thing, and it has a set of extensions that it says are its core extensions, which is essentially the Postgres community says that, yes, these are not part of the core code, but we are going to support it. We endorse it. This is not one of those, though, so it's a third-party extension. This is basically me enabling everything, every kind of audit that it provides, and so you can see it it can basically audit everything that's happening in your database. Really useful if you have to comply to some government-related policies and stuff, and so you want to have a record of all the changes. This is the way to go. Postgres 10 has new monitoring rules. Up until Postgres 10, Postgres did not have specialized monitoring roles. So there were problems in the sense that when you needed to monitor your database, you could either provide a super user to do that. So basically a super user getting into your database and reading your catalog information, or if you used a normal user, it couldn't glean all the information from the catalog tables. Postgres 10 has all of these specialized monitoring roles that are not super users, and so you can treat them like group roles, assign them to your monitoring role, and go from there. On to encryption and PCI. So first, encryption. For at-rest encryption, when you're storing data inside the database and you want it encrypted, PG Crypto is a core extension. It's an extension supported by the community, and that can help you encrypt data within the database. 128, 192, and 256 are the 3 algorithms it supports right now. And there's an, whoops. Am I audible still? Yeah, okay. So there's an obvious performance impact. So only encrypt columns that you need to encrypt. Don't encrypt the whole database, definitely, and don't encrypt the whole table if you don't have to. So most times you need to do this is when you have sensitive data like credit card information. And if you have a single table having credit card information, sensitive columns can be the credit card number and a few more columns maybe, but definitely not the whole table. So it's a waste of your computing resources to have to encrypt and decrypt the whole row every single time it's coming into the database and being called out. Backups can be encrypted as well, depending on what kind of backups you're doing. If you're doing the logical backups, which in Postgres happens with the PG dump, same as MySQL dump, you can encrypt it after the dump has been performed. And if you're doing a file system backup, you can either have, so you can still use an external key, or you can have something like ZFS, which is essentially a volume encryption, and encrypt the whole file system from scratch. And finally, instance level, there is a third-party patch for this. I'm going to upload my slides so you can click on that and actually view it. Not supported by the Postgres community, just sort of a test that whether or not it can be done. So basically what this is when you turn on the Postgres database, when you turn on the cluster, can you do it using 2 separate keys? Basically, anyone here familiar with Oracle's TDE, transparent? Yeah, so it requires 2 keys parts of the key to come together to start the database, right? So something like that. So there is an option, but not supported by the community. For monitoring purposes, especially for PCI, you need additional monitoring. You want to know if any queries are suspicious, any queries that are not authenticated are running against your database. PG stat statements is another core extension for this purpose. So what it does, here I have my cron jobs selecting data from tables that PG stat statement is used to enter data into. So what's basically happening here is that I have monitor tables. One of them, which is the monitor config, has all the authenticated queries. So all my queries that I say that, okay, you're allowed to run on this database, they're all stored in there. And the monitor log is the table where PG stat statements filters out, keeps reading what's running against the database and puts the queries in. So this contains the actual list of queries running. My cron job runs every minute and checks between the 2 tables that is there any query in monitor log that isn't there in the monitor config. And if there is, that means that that query is unauthenticated, unauthorized. So it's going to page the DBAs and send the emails to appropriate parties if it sees an unauthorized query in this fashion. So this is essentially, this is a proof of concept in that you can largely enable PCI compliance without using any third-party extension, without having to pay any third-party software, just using core Postgres and core extensions alone. Whether or not you decide to do that or you decide to use external token services, key management is still something you will have to see about. So the first thing is, where do you want to store the keys? And the second thing is, where do you want to perform the actual encryption and decryption? For both of these, you can have them done either on the server side where your database resides, or on the client side, or on a third party. Why is this question important? Why is it important to decide on this? Is mainly because encrypted query processing is becoming more of a thing with the Internet of Things becoming more common. And so the desire is basically that either have all the keys with the client so that nobody on the server end, like a DBA, can view their encrypted data, because this is very private information based on what IoT device that is. And so another alternative is that, how about we have a database that can actually perform encrypted queries? So you don't actually have to decrypt the data at all, and you can use different kinds of algorithms, and this is an area under active research right now. There is only one database that does this right now, and that's CryptDB. It's based on MySQL, but I don't think it's in active development anymore. It was a proof of concept again. But yeah, it's becoming more of a thing. It's under active research, so things like where your keys are getting stored are actually important now. Replication. Why are we talking about replication in a security talk? Because it matters where you perform the authentication and where you have your password details, your replica's password details. One thing to note here is we talked about encryption and PCI just in the previous segment. So if you do have a PCI database, you do not want a read-only replica. That is a vulnerability. Why is that? Because if you have to comply by the PCI rules, you have to make sure that everything that's being done in your database is being monitored. So we saw previously how PG stat statements extension was being used to do that. If you have read-only replicas, nothing can write to it, obviously, so you cannot have a PG stat statements monitoring that, because it has no place to write to on that slave. So what happens is that if you have a read-only replica, even though you're a DBA, you can log in and you can read stuff and it will not be monitored. So that's a huge, huge vulnerability. So don't have read-only replicas. Have old-fashioned replicas that cannot be read from. No hot standbys. Another thing to keep in mind is if you're using orchestrators, configuration management tools, make sure you're using encrypted data bags, Ansible walls. I'm sure Puppet has something similar, but I don't use Puppet. But yeah, make sure that your passwords that are going from one machine to another or being distributed from a central repository are being distributed in an encrypted fashion. And finally, when Postgres replication requires a recovery file on the replica, in the replica's data cluster. And this recovery file is basically laying out the details about where to connect to replicate from. And obviously that needs the password information. You can provide the password in plain text, but please don't do that. There are alternatives for doing that. There's a PG pass file. You can have a dot file in the Postgres home directory that can have this information, and you don't have to mention it in the recovery file. There are other ways as well. It's, if you're interested, you can look at the documentation, but the most popular way seems to be to put it right in the recovery file in plain text, and that's not great. Logical replication, which is new in Postgres 10, requires you, if you're creating a publication, you require the create privilege. If you're adding tables, you should at least be the table owner. There is an option to add all tables in a schema, but for that, you have to be a super user. Everything subscription related requires you to be a super user too. The one caveat here is that all these privileges are only checked at the start of the replication. So the first time the replication starts happening is the time Postgres actually checks if a user trying to subscribe is a super user. And it is possible to change or have a user with reduced privileges once the logical replication is already happening. So there can be edge cases there. Finally, upcoming features in Postgres 11. We talked about Scram towards the beginning of the talk. Postgres 11, going to be released in the third quarter of this year, is going to have SHA-256 plus. What does plus stands for? It stands for channel binding. So Scram usually stops after authentication, but channel binding is something that you can make sure that even post-authentication, how are you going to make sure there's no man-in-the-middle attacks? And so it basically makes sure that there is mutual authentication happening. There is TLS. So TLS unique is the default algorithm used for this purpose, which basically takes part of the TLS information and uses it to bind to the channel, to bind all the messages happening after the authentication to that very channel, to that very session. There is another way to do it, another algorithm, TLS server endpoint. Postgres definitely has plans to include other algorithms here, but Postgres 11 limits itself to these two. There are some extra test suites for authentication types. These are mostly under the hood kind of thing. And finally, there's large object support. So Postgres has toast tables. And these are tables where if you have JSONB or extended type columns that are really large to store in the table, Postgres is going to create additional table for it that is going to be transparent to the user. So it's going to store all the blobs in a separate table. And that table is called a toast table in Postgres. So those tables up until now did not have a very defined separate ACL permission granting ability so far. But Postgres 11, you can grant them special privileges that the actual table, the table that uses those tables, doesn't have. Finally, the desired features. Data redaction would be great to have. Again, when it's about PCI, even if the DBA or somebody on the data analytics end is querying back for some information, it would be nice if Postgres has some core feature to redact part of the credit card data, just as an example. Oracle TDE is great for key management, and something like that to have in Postgres would be absolutely amazing. I encourage reading that white paper if you're interested in PCI, and yeah, it's pretty neat. And finally, show grants in MySQL, which I'm sure here MySQL users take for granted. I really like that feature, and that feature isn't available in Postgres. So right now, you can't really do a show grants in Postgres and see what privileges, all privileges that your role has. So that would be definitely a welcome feature in Postgres. Please feel free to rate my session, and thank you, and I'm available for questions in private. Thanks. You can make it. So no, it doesn't have a feature inbuilt that says that it's PCI compliant. So what I talked about in this session is how you can make it compliant. So you can actually implement all the compliance policies, compliance requirements by yourself, which is not ideal, but it's possible. If you're really strapped for cash, it's possible to do it for free. Yeah. Thanks.
Do you have a link to your slides?
Yes, I think I already have a link on omniti.com/presents, and I'm also going to be uploading it. And if you follow the Postgres Planet Postgres blog on Twitter, you should see it soon.
So I would say the only thing missing from your slides is you should mention the things like KMS support under AWS.
It doesn't have it.
No,
Yeah.
but it should be added, right? Or your startup script can get it.
So I've had discussions actually very recently about KMS with AWS folks, and it seems like that is not a priority for the community right now. And so AWS is going to have to either take the lead or implement it themselves. It's not me saying it's not a priority, it's just that from what I've been seeing, it's not a priority security-wise.
No, but for sophisticated end users, they could use it now if they wanted to,
Yeah,
But the point is, KMS gives you a power that wasn't available to most users until that was released.
definitely, yeah. And another thing I did not mention was password verification and password strength. You do have something in Postgres, but that doesn't work with MD5 and Scram encrypted passwords. It only works if your password is in plain text. So that's not really useful. So,
Oh, really? Okay.
yeah. Definitely some room for improvement there, but I don't see any rush for that in the community either. Thanks.